Alright, so we're looking at the set number 2. Well, this particular set is actually a bit difficult. I will not say it is difficult simply because it is too much of logic. It's a bit lengthy, and that is the reason why I would say it is above moderate. Definitely, it is not easy. I would not call it as a moderate level also. It is definitely above moderate level. Okay, so when you're looking at sets like this, don't jump into them directly. Please make sure that you understand the depth of the set. There are 3 parameters in this. So we are talking about a set where there are people. In fact, you're talking about people's name. So that's the first parameter. You are supposed to map that with the second parameter, which is the birth year. Then the third parameter, which is the hospital you are born in. And the fourth parameter, which is the person's mother's name. So you're talking about mapping 4 parameters, or rather 3 parameters mapping to names. So totally, if you're looking at, it's a 4 parameter set. So when you get into these kind of sets, be very careful. It should be a conscious choice. But let's go ahead and take a look at what is given to us. So all this information is there. We are talking about, and of course, there's a 5th parameter also, small parameter, which is badminton, table tennis, and volleyball. So 5 parameters you have to map, not an easy task. So the first statement says, for any person, the first letter of his name, the first letter of the hospital, and the first letter of the mother's name are all different. So I know you can start by making a table like what I made. So these are the names of the people. These are the hospitals. And these are the mother's names. Right? So this is how I'm going to treat or solve this set. So you can make a table like this. You don't need to make a table also, but it's a good habit if you are able to make a table. So first, N and N cannot be mapped, and N and mother's name N cannot be mapped. Similarly, K and K cannot be mapped. B and B cannot be mapped. D and D should not be mapped. Similarly, A and A should not be mapped. And you have R and R not being mapped. So because it is clearly mentioned that the first name, starting letter of the person, the starting letter of the hospital, and the starting letter of the mother's name are not matching. So that's the first statement taken care of. Let's go to the second statement. Amrit's year of birth. So Amrit's year of birth is 1 more than the average of the births of David and Rakesh. It is 1 more than the average of David plus Rakesh by 2. Keep it aside, we are not using it. So I will just put a bracket here which says this information is not used in the table for me right now. None of David, Rakesh and Amrit were born in Kaka Hospital. So DRA are not in Kaka Hospital. This I can straight away use. So D is not Kaka, A is not Kaka, and R is not Kaka Hospital. So my indication is if I put a line basically and no bracket, it means the information has been used. Bracket means the information is left out for me. That's my symbols that I have devised. You can devise your own symbols. Neha, who was not born in Dhaka Hospital, I can immediately write this. Neha, not in D Hospital. Right? So Neha, who was not born in Dhaka Hospital, was 1 year older than the person who was born in Dhaka Hospital. So now we don't know who's in Dhaka Hospital, but once we know that, we can find Neha is 1 year older or vice versa. The person who is a national table tennis player was born in Raka Hospital to Niharika. So Niharika's child is a table tennis player and born in Raka Hospital. So Raka and Niharika. So Raka is table tennis, Niharika is table tennis. Okay, so the vertical columns for R and N should be table tennis. Next, so this is taken care of. I'll put a tick mark, which means nothing is left out in the set. If there's no tick mark, which means basically something is left in the set, and that something is given by my bracket. Right? That's my idea. Then what else? The difference between the ages of Rakesh and Keyur. So mod of R minus K. Now the reason why I put a mod is because I don't know who's elder. Right? Is 5 years. And none of them were Bina's children. This I can mark. So this I will put a bracket, which means I have not used this right now in the table. But none of them are Bina's children. This I can utilize. So R and K are not Bina's children. So R, where is R? R is over here. R and K. So K is not Bina's and R is not Bina. Okay. So this is basically what I have. Next, moving on. Where was I? Yes. The volleyball player was born in Aka Hospital to Bina. So Aka Hospital, volleyball, and Bina, volleyball. Right? Now let's still continue. I have G, statement G. Kokila is the mother of the person who was born in a year which is a perfect square of a number. Now if you notice, the years are 1932 to 1939, because the question said 31 to 40 both excluded. So included values are 32 to 39, and you can see that there is only one perfect square, and the perfect square is 44 square, which is 1936. So 1936 is the only perfect square that you will get. So you can just, if you want, you can just verify. In fact, if you ask me how do I get this, so the way to look at this is look at the squares which are close to it. What is 40 square? 40 square is 1600, clearly less than what you want. What is 42 square? Do a 42 square. So 42, this is 2 to the 4, 8, 4 to the 8, 4 to the 16, 4, 16, 7, 17, 64. So basically you are coming nearer to it, not yet enough. So you can try 43, you can try 44. So 44 into 44 will give you 4 4 are 16, 16 plus 1, 17, so 176. So you'll get 6, 3, 1, 7, 8, 9, 1936. You can see that's a perfect square, and there's only one perfect square you'll get. So we can erase all of this, and you can say that Kokila is the mother of the person who was born in a year which is a perfect square. So Kokila, this person's child is 1936 born. Okay. And has been a national badminton player. And so the player is badminton player. So this is badminton. Okay. So G I have utilized entirely. Nothing is left in the point number G. Right. So now the point number H. If you're looking at point number H, basically the point number H says, very interesting, if you are dividing the year with the last two digits, leaves a remainder that is equal to the first two digits. So if I take, for example, 1931 and I'm dividing it by 31, I should be getting the remainder as 19. That's what the statement means. Which year is it? So I'm checking for 1931. So 31 goes 6 1s are 6, 6 3s are 18. So 71, 31 goes 2s are 62. So the remainder is actually 9, not 19. So 1931 is not your value. Similarly, check for other numbers. One number will satisfy that. Which number is that? Let's see, I want to check for 1933. So 1933, if I check, you will start with 33. So 33 goes how many times? 6 times, 18, no, not 5 times. 5 3s are 15. 5 3 is 15 plus 1, 16, 165. So this is 8, 1, 6, 7, 8, 283. Right, 283. Now 283, I will take 8 times, 8 3 is 24, 2, 8 3 is 24, 25, 26. So you can see the remainder now is 19. So the year which is referring to is 1933, 1 year. So David was born in 1933. So that's the statement. So David was born in the year 1933. Okay. And this is entire thing is done. He is 4 years older than the person whose mother is Renu. So Renu's mother is 4. So the person whose child is Renu is 4 years younger, or David is 4 years older. So the other person should be 19. So David is 1933. The other person should be 1937. 4 years difference. Right? So 1937 is the person whose mother is Renu. So Renu should be 1937. Next, so here I have utilized all the information. Nothing is left out. Then Bipin, the oldest of all. Now, if you notice, we have from 32 to 39, out of which we already have a 33 year being used. And we have Bipin, who is the oldest. So there is only one more year which is older than 33, which is 32. So Bipin has to be 1932. So Bipin has to be 1932. Right? Bipin has to be 1932. Was not born in Naka hospital. So Bipin, the oldest of all, was not born in Naka hospital. So Bipin is not Naka. Right? And her mother's name is neither Dharti nor Niharika. So Bipin is not born to either Dharti or Niharika. So Bipin, not D and not N. Right? So this is the information. Now, where else? Okay, so we have utilized this information completely. So in this slide, everything is used. Nothing we have to worry about. In the first slide, now we are talking about this piece of information, this piece of information. Niharika also we did not use fully. Anything else? Rakesh, the volleyball player was born in Akka hospital. So this we have utilized. So now let's start looking at what could be the value of D and R. So we already got the value of D, I believe. D is 1933. So take a look at it. So A should be 1 plus 1933 plus R by 2, whereas R minus K is 5. Now first of all, look at the years. 5 years differences. What could it be? Now 1932 and 1937 is one pair. 1933 and 1938 is another pair. 1934 and 1939 is the last pair. These are the pairs of numbers. But we already know 1933 and 1938 cannot be possible because 1933 is David. So it cannot be. Now we are searching for R and K. We want the pair to be belonging to R and K. So R and K cannot be the second pair. First pair also is not possible because 1932 is Bina, the oldest. So one person is gone. Already 1932 is taken. So 1937 cannot be Raka or K because other person has to be here. So that's not possible, which means only one possibility exists. Now the question is, who is Raka and who is Keyur? Right? R, not Raka. Raka is Rakesh, sorry. Rakesh and Keyur. So which year is Raka, which year is Keyur? You'll have to make sure that this person A is an integral value. Right? A is an integral value, which means this is an odd number. Odd number plus odd number only will give you a division by 2 as an even number. Otherwise, it is not possible. So this should be Rakesh and this will be Keyur. So R should be, this should be Keyur and this should be Rakesh. 1939 should be Rakesh because 1939, so we'll get 1933 plus 1939 by 2. Only then your A will become an integer. So what will be your A? So this will be 1 plus 33 plus 39. So that is 1972. So that is basically you're looking at only year, 72 by 2. 72 by 2 is 36. So 36 plus 1 is 37. 39 plus 33, I'm just taking the, I'm not worrying about this 1900s. 1900s you can just leave out. So 39 plus 33 is 72. So 72 basically means I'm looking at divided by 2, that is 36 plus 1 is 37. So A is born in the year 37. So A is born in the year 1937. And we already got two more values. What are the two more values? Keyur is 1934 and Rakesh is 1939. So Keyur 1934 and Rakesh 1934 and Rakesh is 1939. And who is the other person left out? Only Neha is left out. But let's start filling the table now. If you notice, 1934 Keyur cannot be 1937 because this year has to match. Similarly, 1932 cannot be here, 1933 cannot be here, 1937 has to be here. So this is a cross and all these will be crosses. Now 1939 cannot be here, 1933 cannot be here because this is 1936, and what else? 1932 also cannot be here because this is 36, which means this is a tick, the others are all crosses. Then where else will we have? Is there anything else? Yes. Start looking at it. So 1934. Okay, this person is 1932 here because this tick mark should be mapping to your B. So 1932 should be coming here. Then this tick mark is 1937. So 1937 is already mapping. Now 1936, only one tick mark here is left out. So these are crosses. So this tick mark should become 1936. And you can see 1936 is Neha. And if you look at this statement, Neha was not born in Dhaka hospital but was 1 year older, which means the person who is born in Dhaka hospital should be in 1937. So who is 1937? Aka. So Aka is born in Dhaka hospital. So these are crosses. And these are also crosses. So you'll start filling in information like this. Then what else is, what else can I fill? Look at 1933 we have. Yeah, one more thing that you need to fill is, look at it. Table tennis and table tennis. So when you're looking at vertical columns being table tennis, the vertical column ticks and crosses should be exactly same. The reason is quite simple. If you say this is a tick mark, which means tick mark for table tennis, here also there should be a tick mark, but already there is a cross. So I cannot have a tick mark here. So the logic I hope you're able to understand. I should be mapping my vertical columns for table tennis should be exactly identical. So if there is a cross here, there has to be a cross here. There is a cross here and cross here, it is matching. If there is a cross here, this has to be a cross. If there is a cross here, this has to be a cross. Similarly for volleyball also. So by the way, volleyball already I got a tick mark here, which means volleyball is 1933. Okay, so this person is volleyball, and already this will be a tick. A cross mark because the tick is already there. So basically the remaining is like Sudoku filling of your ticks and crosses, right? So this year will be 1934. Then you will have this year 1939. And okay, now coming to the hospitals. So hospitals, what is happening here? Let's start looking at it. Which hospitals will we be able to fill? Yes, so now volleyball and volleyball should be mapped identically. So wherever there is a cross here, the cross here should be taken forward to the left hand side also. So if there's a cross here in volleyball, I need to have a cross here in volleyball. Cross, cross, and tick should be mapped, and cross. So basically this person 1933, right? So 1933 and 1933 will be mapped. So this is how you map. So once this is done, all these will be crosses, which means this will be a tick. So this will be cross, then this will be a tick, which means this will be crosses, then this will be a tick, and this will be a cross, and this will be a tick. So you get your entire table in front of you, and this is how you solve a 4 or 5 parameter table, right? So now let's go ahead and quickly take a look at the questions. In which year was Keyur born? Keyur, was this person born in the year 1934? So this is 1934. In which hospital was Amrit born? So Amrit was born in the hospital Dhaka, D, right? Who is the son of Aarti? So Aarti is here. Aarti's son, this tick mark is coming to B, right? It is Bipin. Son, daughter, whatever, right? Because in the it could be anything, doesn't matter, but it's Bipin. Then we have who has been a national table tennis player? So who is a national table tennis player? Table tennis is Neha's child. This is a tick mark here. So it is K, right? So this is TT. So it is K. Keyur, where is Keyur? Yes, option B. For how many people can the year of birth, hospital name and mother's name be uniquely determined? If you notice in the table, nothing is left unknown. Everything is known. So everybody's things are mapped. So all 6 people, you know everything. So the answer here should be 6. The persons who were national players were born in which set of years out of the following? So who are the players, national players? Look at it. 1936, 1933 and 1934. So 34, 33, 36. So 33, 34 and 36. Option A. And that completes your set. A typical set like this, in an exam, if there are 6 questions, it is worth spending even 10 to 12 minutes. But please make sure that at a 5-minute point, you ask yourself, are you stuck in it or are you making progress? Within 5 minutes, if you don't know what to do, please leave such a set and move on to the next set, because this is very, very tricky set. If you miss 1 or 2 points, you can't solve the set, right? Moving on to the next one.